Welcome to the Before AGI podcast. Today, we're going to be taking a deep dive into the world of transformers.
Oh, yeah, Transformers.
These revolutionary AI models you hear so much about.
Yeah, you hear them buzzing about everywhere these days.
They really are. And they're behind everything from ChatGPT to Google Translate, even predicting protein structures.
Yeah, it's true. They're really changing the AI landscape. And what's so fascinating about them is how they approach language.
Yeah.
They don't read words one by one like we do.
Right.
They analyze the entire sentence at once. And they can capture these subtle connections that even humans might miss.
It's incredible. It's
Yeah.
like they have a bird's eye view of the whole sentence.
Exactly.
So how do they actually work? I mean, there's this thing called self-attention.
Right.
That sounds pretty mind-bending.
It is mind-bending, but it's also the key to their power.
Okay.
Imagine a group of people each holding a word from a sentence.
Okay.
And they can shout questions to each other to try to figure out what the sentence means as a whole.
Okay.
That's basically self-attention.
Okay.
It allows the model to understand the context of each word and how it relates to all the others.
Okay, I'm starting to get the picture.
Good.
But let's back up a bit.
Yeah.
How do you even feed words into a neural network?
Right.
I mean, they need numbers, right?
Exactly. That's where word embeddings come in.
Okay.
It's like translating words into a language that neural networks understand.
Numbers.
Numbers, exactly.
Okay.
Think of it as turning words into coordinates in a giant multidimensional space.
Okay.
So words with similar meanings end up close together,
Okay.
and words with different meanings end up far apart.
So you're saying king and queen would be closer together
Yeah.
than, say, king and banana.
Precisely. And it gets even cooler.
Oh, boy.
The model can learn relationships between words.
Oh.
Like the classic example,
Okay.
king minus man plus woman equals queen.
Wow.
This was actually demonstrated in a paper called Attention is All You Need.
Which introduced the transformer model.
Okay.
It's like the model is doing math with words,
Right.
uncovering these hidden connections and analogies.
Hold on, we can do math with words now.
Yeah, it's free.
It's amazing.
Yeah.
The AI Hacker YouTube video shows even more examples of this. It's mind-blowing.
It is pretty wild.
So we've got these words turned into coordinates.
Right.
But how do they actually flow through the transformer architecture?
So let's break down the transformer like a recipe.
Okay.
First, we have the input text,
Okay.
which gets chopped into tokens.
Mm-hmm.
These can be words or even parts of words.
So like transformers might become transinformers?
Exactly.
Oh.
Each token is then matched to its vector representation.
Right.
Its coordinate in that giant word space.
Mm-hmm.
But since transformers look at the whole sentence at once,
Yeah.
we need to tell them the order of the words.
Otherwise, they'd just have a jumbled mess of words.
Right. So that's where positional encoding comes in.
It's like giving each word a little tag that says, hey, I was the third word in this sentence.
Clever. So they've got the words.
Right.
They know the order.
Uh-huh.
Now they need to start talking to each other. This is where self-attention comes in, right?
Exactly. Self-attention is where the magic happens.
Okay.
It lets each word look at all the other words in the sentence and figure out which ones are most relevant to understanding its meaning.
Okay.
For example, in the sentence, the cat sat on the mat because it was tired.
Okay.
The word it is going to pay more attention to cat than to mat.
So each word is basically asking, hey, everyone, what do I need to know about you to understand myself better?
That's a great way to put it.
Okay.
They do this by calculating what are called attention scores. The higher the score, the stronger the connection between two words.
Okay.
And to get an even richer understanding, they do this multiple times,
Okay.
focusing on different aspects of the sentence each time.
Okay.
We call this multi-head attention.
Multi-head attention. So it's like having multiple perspectives on the same sentence.
Exactly. One head might focus on subject-verb relationships,
Wow.
while another looks for adjectives and so on.
Okay.
This was actually inspired by an earlier paper
Oh, really?
called Neural Machine Translation by jointly learning to align and translate,
Yeah.
which used a simpler version of attention after all this attention.
Yeah.
Each word's vector has a much deeper understanding of its role in the sentence.
It's like each word has absorbed the context of the entire sentence, right?
Exactly. And from there, the transformer can use this rich understanding for a variety of tasks, like translating languages or summarizing text.
Okay.
But before we get into those specific applications, there's still more to explore within the transformer architecture itself.
There's more. This is already so complex. I'm hooked. Tell me more.
Well, we've talked about how the transformer takes in words and understands their relationships,
Right.
but we haven't discussed how it actually processes this information to generate outputs like translations or summaries. That's where the concepts of encoders and decoders come in.
Encoders and decoders. Okay, now I'm really intrigued.
Yeah.
What are those?
So think of the encoder as the part of the transformer that reads and understands the input text. It's like the brains of the operation, taking those word vectors we talked about and building this complex representation of the entire sentence.
So the encoder is kind of like a detective.
Yeah.
Gathering all the clues
Right.
and figuring out what this sentence is really about.
That's a great analogy.
Okay.
So the encoder uses those attention mechanisms that we discussed,
Right.
allowing words to kind of interact and figure out their relationships.
Yeah.
And it's a multi-layered process, with each layer refining the understanding and building a deeper representation of the sentence.
So it's like each layer adds another dimension to the picture.
Yeah.
Okay, so we have this encoder that's really good at understanding the input. But how does the transformer actually use this understanding
Right.
to do something like translate a sentence?
That's where the decoder comes in.
Okay.
The decoder takes the encoder's output, that rich representation of the input sentence, and uses it to generate the desired output, whether it's a translation, a summary, or even a creative text.
So the decoder is kind of like a builder using the blueprint created by the encoder.
Exactly, to construct something new.
Gotcha. So the decoder also uses self-attention.
It does, but it's focused on understanding the relationships between the words in the output sequence.
Okay.
So it generates the output one token at a time.
Okay.
Starting with a special start token, and then uses its attention mechanisms and the information from the encoder to decide what the next word should be.
So it's like a step-by-step process with the decoder carefully choosing each word based on what it's learned from the encoder and what it's already generated.
Precisely, and to make sure the decoder doesn't cheat.
Right.
By looking ahead at the words that haven't been generated yet, we use a technique called masking.
Okay.
This prevents the decoder from attending to future tokens, ensuring that the output is generated sequentially.
So it's like giving the decoder a blindfold.
Yeah.
So it can only see the words it's already written, forcing it to think creatively and rely on the information from the encoder.
That's a great way to visualize it.
Okay.
This interplay between the encoder and the decoder is what allows transformers to perform such a wide range of tasks.
This is fascinating. It's like the encoder and decoder are having a conversation with the encoder saying, here's what this sentence means. And the decoder responding, okay, based on that, here's how I'll express it in another language, or here's a concise summary of the key points.
That's a very insightful way to think about it. And remember, all of this is powered by those incredible self-attention mechanisms we talked about earlier.
Right.
Each word, whether in the input or output sequence, is constantly interacting with the other words, figuring out its role in the bigger picture.
It's like every word has a voice, and they're all working together to create meaning.
Exactly. And the beauty of this architecture is that it's highly scalable and adaptable.
Right.
We can train transformers on massive amounts of data, and they can learn to perform incredibly complex tasks.
That's what makes them so powerful.
It is.
But we touched on some of the challenges earlier.
Right.
Can you remind us what those are and how they might impact the future of transformers?
One of the biggest challenges is computational cost.
Okay.
Training these massive models requires enormous amounts of data and processing power, which can be expensive and have a significant environmental impact.
Right. We can't ignore the carbon footprint of all this computation.
Absolutely. And then there's the issue of bias. Transformers learn from the data they're trained on.
Right.
So if that data contains biases, the model might learn to reproduce them in its output.
So if we train a transformer on text that reflects gender stereotypes or racial prejudices, the model might learn to generate text that perpetuates those harmful biases.
That's the danger. It's a reminder that even though these models are incredibly powerful, they're still just tools. And we need to be very careful about how we use them and the data we train them on.
It's like giving a powerful tool to someone without proper training.
Yeah.
It could be used for good or for harm, depending on the intentions and awareness of the user.
That's a great analogy, and that's why it's so important to have these conversations about the ethical implications of AI. And to develop safeguards against potential harms.
Absolutely. We need to ensure that these powerful technologies are used responsibly and for the benefit of society as a whole. But despite these challenges, the future of transformers seems incredibly bright.
It is Researchers are constantly working on making them more efficient, less biased, and even more versatile.
Okay.
We're seeing exciting new applications emerge all the time.
Like what? Give us some examples of how transformers are being used in the real world.
Well, we already mentioned ChatGPT,
right,
which uses a transformer-based model to generate human-like text in response to prompts.
Okay.
It's being used for everything from writing creative content to answering questions to even coding.
It's like having a personal AI assistant that can help you with all sorts of tasks.
Exactly. And then there's Google Translate, which also uses transformers to achieve unprecedented accuracy in language translation.
Right.
It's breaking down barriers between cultures and making communication more accessible than ever before.
That's amazing. It's like having a universal translator in your pocket. What other applications are out there?
Transformers are being used in fields like medicine.
Oh, wow.
Where they're helping to diagnose diseases, analyze medical images, and even design new drugs.
So they're not just good with words. They're tackling some of the biggest challenges in a variety of industries.
That's right. And we're only just scratching the surface.
Right.
As these models continue to evolve, we can only imagine the incredible possibilities that lie ahead.
This has been such a fascinating exploration of transformers.
It has.
We've covered so much ground.
Yeah.
From the basics of word embeddings to the intricacies of self-attention encoders and decoders.
There's been a lot.
And we've only just begun to delve into the real-world applications.
Right.
And the ethical considerations surrounding these powerful technologies.
Sure.
Before we move on to our final part, I want to remind our listeners to check out Ochieng.
Oh, yeah. You know what it is.
Yeah, YouTube channel for some fantastic tutorials and insights.
He's great.
He breaks down these complex topics in a clear and engaging way, making them accessible to everyone.
Yeah, he's a fantastic resource for anyone who wants to learn more about AI and delve deeper into these fascinating topics.
Absolutely. We'll be back soon with part 3 of our deep dive into Transformers. Stay tuned. Welcome back to the Before AGI podcast. We've covered a lot of ground in our deep dive into Transformers.
We have.
Exploring everything from those mind-bending self-attention mechanisms to the intricate dance between encoders and decoders.
Yeah, it's been a wild ride.
It really has been. But before we wrap up, I'm curious about something. We talked about attention and how it allows words to interact.
Right.
But what happens after that? How does the transformer actually process this information? And refine its understanding?
That's a great question. There's another crucial component we haven't discussed yet.
The
multi-layer perceptron, or MLP.
MLPs,
You'll also hear it called a feed-forward network.
Gotcha.
These MLPs are found within both the encoder and decoder stacks, adding another layer of depth to the transformer architecture.
Okay, MLPs.
Yeah.
I'm intrigued. Where do they fit into this whole process?
So think of the attention mechanism as a spotlight, highlighting the most important relationships between words in a sentence.
Okay.
The MLP then takes this illuminated information and dives deeper, extracting even more meaning and nuance.
So attention figures out which words are important.
Right.
And then the MLP steps in to really understand what those connections mean.
Exactly. The MLP takes each word's attention-enhanced representation and analyzes it individually. It's not about interactions between words at this stage, but rather about deepening the understanding of each individual word within the context of the sentence.
Interesting. So it's like each word gets its own private interrogation room with the MLP. Where it's grilled for even more information.
That's a very vivid analogy. And as with attention, this interrogation process involves vectors and matrices, those building blocks of deep learning. Inside the MLP, you'll find layers of interconnected nodes, each performing a mathematical operation on its inputs.
So it's like a chain of mathematical detectives.
Yeah.
Each one uncovering another layer of clues about the word's meaning.
Precisely, the specific operations performed by these nodes are determined by the weights of the network, which are learned during training. As the model sees more and more data, it gets better and better at adjusting these weights to extract the most meaningful information.
It's like the model is developing its own intuition about language. based on the patterns it's observed in massive amounts of text.
That's a great way to put it. And after each layer in the MLP, we apply what's called a nonlinear function, which adds complexity and allows the network to learn more intricate patterns.
Nonlinear functions, that sounds a bit intimidating.
Don't worry, they're not as scary as they sound.
Okay.
Think of them as adding curves to the relationship between input and output.
Okay.
Without them, the MLP would just be a series of straight lines, which wouldn't be very expressive or powerful.
So nonlinear functions are like adding spice to the recipe, allowing the MLP to capture the full richness and complexity of language.
Exactly. And by stacking multiple layers in the MLP, each with its own set of weights and nonlinear functions, we create a very powerful system for refining the representation of each word.
It's amazing how all these pieces fit together.
It is.
We have the attention mechanism weaving connections between words. The MLP is diving deep into each word's individual meaning. And the encoder and decoder working together to translate this understanding into action.
It's a symphony of computation. A testament to the ingenuity of the researchers who developed this architecture.
And remember, all of this comes together through the magic of training.
Yes.
We haven't talked much about how these models actually learn.
Well, training is where the data comes in. We feed the transformer massive amounts of text, and through a process called backpropagation, the model adjusts its weights to minimize the difference between its predictions and the actual data.
So it's like showing the model a million examples of correct translations and saying, figure out how I did that.
That's the essence of it. And as the model sees more and more data, it gets better and better at understanding the nuances of language and performing those complex tasks we've been discussing.
This is truly mind-blowing. It's incredible to think that a machine can learn to understand and generate language at such a high level.
It is.
But before we get carried away by the possibilities, we need to remember the challenges we discussed earlier. Computational cost and potential bias.
Absolutely. Those challenges are not to be taken lightly. We need to develop more efficient training methods and ensure that the data we use to train these models is representative and free of harmful biases. The future of transformers depends on our ability to address these challenges responsibly.
It's a reminder that even the most powerful tools can be used for good or for ill. It's up to us to guide their development and ensure they're used ethically and for the benefit of all.
Well said. It's an exciting time to be working in AI, and transformers are at the forefront of this revolution. Who knows what incredible advancements await us in the years to come?
It's a future full of possibilities, and for our listeners who want to explore those possibilities further, we highly recommend checking out Ochieng AI YouTube channel.
Oh, yeah. Great channel.
He offers fantastic tutorials and insights that break down complex AI concepts in a clear and engaging way.
He's a fantastic resource for anyone who wants to delve deeper into this fascinating field.
Absolutely. And don't forget to subscribe to the Before AGI podcast for more deep dives into the world of artificial intelligence. We're exploring the cutting edge of AI, one fascinating topic at a time.
Thanks for joining us on this journey into the world of transformers. Until next time.